Okay, so here I have a series parallel problem. My formula in determining voltage, resistance, or intensity for representing amperage is up above. Here I need to determine how much amperage is flowing through the circuit and how much each load is dropping in reference to voltage. I know that my voltage total is 12 volts. I need to determine my resistance total and my intensity total, or my amperage total. And to do that, I focus on my parallel portion of the circuit. I do not do anything with this load or this resistor. In looking at this portion, I am going to use a method for solving. And that is my 1 over 1 method. So I take 1 over each load. So you'll see that I've done 1 over 3 and 1 over 2. In order to add this fraction, I need to find a common denominator. And so this would represent 2/6 plus 3/6, which would equate to 5 over 6. And as I figure that out, 5 divided by 6 equals 0.8333 to the fourth spot. Now I still have my 1 over here, so I need to put 1 over 0.8333. And that equates to 1.2000. So that is my resistance total for just this portion of the circuit. So to simplify things a little bit better for you, I can redraw this so I can understand what's taking place. I've got my circuit. This is my battery. I've got this first resistor, which is 1 ohm. And then I've got this portion right here. And I've determined how much resistance is for the total parallel portion. And that is 1.200 ohms of resistance. Now we know that in a series circuit, total resistance is the sum of all resistors. So what I need to do is I need to add these two together. And that'll help me factor in how much my resistance total is. So 1 plus 1.2000 is 2.2000. That is my resistance total. If I look back here at my formula, to find my intensity or my amperage, I need to take voltage divided by resistance. So that is 12 divided by 2.2, which equals 5.4545. That's my amperage total. I know that I have 5.4545 amps flowing through the entire circuit. This first resistor is going to see all current, but when I get to a parallel circuit, the current splits off. And so my very first step in figuring out the next portion of this problem is taking my current, the 5.4545, times my 1 ohm resistance. So intensity times resistance is going to equate to my 5.4545 volts dropped, right? I use my formula up here. So resistance times intensity. So I've got 5.4545 volts dropped. That means out of 12 volts, I will have the remainder for both of these branches. So 12 minus 5.4545 equals 6.5455. And I will have the same amount of voltage for this other parallel portion of the branch. Now I've got my volts and I've got my resistance. How do I factor in intensity or amperage, I got to do volts divided by resistance. And so 6.5455 divided by 2 equals 3.2727. And I take, for the top one, 6.5455 divided by 3 equals 2.1818. These two amounts should add up to this total. I'm sorry, these two amounts should add up to this total. That's my amperage. And one last step is I can determine my voltage drop. And voltage drop again is going to be my intensity times my resistance, which will equate to 6.5455. Intensity or amperage times resistance, 6.5455.